Okay, so this question says if a particle is resting in equilibrium, then the resultant of all the forces acting on it is zero. This means that sum of the vectors of the forces is the zero vector. So that's the kind of hint for this question, I suppose. So I've got the forces, 2i plus 3j, 4i minus j, minus 3i plus 2j, and ai plus bj act on a particle which is in equilibrium. Find the values of a and b. Okay, so what we're going to do is we are going to add these vectors up. So I'm going to use the column vector notation. So 2i plus 3j can be written like that. If I add these vectors up, it's in equilibrium, then the resultant force of those vectors is going to be 0. So that is the equation that I'm going to form. Okay, so if I now add these vectors together, so I've got, and I'm going to just take the I components and the j components and I'm going to deal with them separately. I've got 2 plus 4 is 6 minus 3 is positive 3, so I've got 3 plus a as my horizontal component. I've got 3 minus 1 is 2, plus 2 is 4, plus b, and that is equal to 0, 0. Okay, so this is now very straightforward. So I've got 3 plus a equals 0. I can just deal with my horizontal components and my vertical components separately. So I've got a equals minus 3 and I've got b equals minus 4. So this vector, this fourth vector that we weren't told, is minus 3, minus 4.